Hi everyone and welcome to the internet. So what we're going to be doing in today's physics lesson is having a look at loudspeakers and microphones. So hopefully by the end of this lesson you're going to be able to describe how a microphone works and how a loudspeaker works. To start us off, we've got some questions based around our previous lesson, so have a go at answering these questions in your books for me. So I'm going to give you about 3 minutes to have a go at this. Okay, let's mark those answers. So question 1, you should have got step up and step down. Give yourself a mark for each of those. For question 2, we need an alternating current, or AC. So if you've got either of those phrases, give yourself a tick. And then for question 3, we've got up to 5 marks available here. So the first one is for saying an alternating potential difference across the primary coil. Second mark produces an alternating current in the primary coil. Third mark is for saying that this produces a magnetic field in the iron core. Fourth mark is for saying that that is constantly changing. And then your final mark is for saying that this induces a changing potential difference in the secondary coil. So what you can do is add it up and give yourself a score out of 8 for that. So in our previous lessons, we've actually looked at 2 other devices, motors and generators. Now, both motors and generators use magnets for their actual function. What I want you to do is describe how a motor uses a magnet and then describe how a generator uses a magnet. So I'm going to give you a couple of minutes to have a go at answering those 2 questions for me about how motors and generators use magnets. Hopefully what we've got are these two answers then. So for our motors, we've hopefully said that they use a current in the wire to produce movement within a magnetic field. And the second one, the generators, use movement to produce a potential difference. So what we've got there are two ways that the magnets are used. The motors obviously generating movement as a result of having a current in a wire within a magnetic field, and the generators using movement to then produce a potential difference as a result of it cutting those magnetic field lines. So if you haven't got those written down, jot those points down now for me. What we're going to do now is have a look at these two different devices, the loudspeakers and the microphones. We're going to start off with the microphone. Now the diagram we've got on the screen here is one we're going to look at in a bit more detail, and if you want to do a sketch of it, then by all means feel free. You can always grab it from the PowerPoint that's on either Google Drives or my website later on if you'd rather just listen, look and make your notes and do a diagram later on, then that's also fine. If we start by having a look at the picture of our dynamic microphone, then this is what we see on the screen. So what we start off with then is the actual setup. So the red lines on the far left, those are the sound waves. We've got a diaphragm, the coil and a magnet that make up the actual microphone. So what we're actually going to do is have a look to see how this dynamic microphone actually works. So the first thing we need to know then is about the sound wave. When we're talking about a sound wave, what we're actually referring to is a type of pressure wave. So as sound travels, what's actually happening is it's creating these areas of high pressure called compressions and areas of low pressure called rarefactions. So what we see is that sound wave is going to travel from your mouth, where it's being generated obviously in your throat, to the microphone itself. So what we're seeing is as that air is coming out of your mouth, we've got these areas where the particles are close together. So we've got the areas of high pressure, the compressions, and we've got the areas of low pressure, the rarefactions. And those are going to travel through the air and then hit the microphone. The part of the microphone those sound waves hit is the diaphragm. Now, the diaphragm itself is going to then move as a result of those sound waves hitting it. So where we get those compressions, the area of high pressure hitting the diaphragm, then it's going to push it in. And the areas of low pressure, the rarefactions, they're going to pull the diaphragm back out again. And you'll notice that the diaphragm is actually resting against and connected to the coil. What that means is that as the diaphragm moves in and out, then the coil is going to move in and out as well. And you can see there that the coil is actually sitting around a magnet. So that means what we're doing is we're moving our coil over the magnet, and hopefully that tells us that what we're going to do is then induce a potential difference across the ends of a wire, because we're going to be cutting those magnetic field lines. And that is our electrical signal that the microphone produces. What I'd like you to do then is, on the screen we've got 3 sentences. So I'd like you to copy these into your books and then fill in those missing words using the box at the bottom. Obviously I've just spoken you through how the microphone works, so hopefully you'll be able to do this. All the words you need are in the table at the bottom there. Write the sentences out, fill in the blanks. I'll give you about 3 minutes to have a go at this. Let's check to make sure we've got those correct words in the right places. So what we find then is our dynamic microphones act like a generator. Now what we're starting off with is our pressure wave, which is a sound wave. So that first word that was missing is pressure. Now what happens is, as that sound wave hits the diaphragm, second missing word, of the microphone, then compressions, third missing word, which are those regions of high pressure, are going to push the diaphragm in, next missing word. And then we've got those areas of low pressure, the rarefactions, and they pull it back out. So what we've got is this movement of the diaphragm in and out as a result of that pressure wave, which is just our sound hitting the diaphragm. So add up your scores for me. You've got a maximum of 1, 2, 3, 4, 5, 6 that you could have got there. So add up your scores out of 6. Obviously, any that you got wrong, make sure you've got the correct word written in, so you do have a proper explanation of how our microphone works, or at least the first part of it. Same thing again here then, we've got another 3 sentences, the missing words are in the box at the bottom, so have a go at finishing off these 3 sentences to finish our explanation of how a microphone works for me. So again, I'm going to give you about 3 minutes to get this done. Let's check those answers then. Hopefully what we went on to say in our explanation is that as the diaphragm moves in and out, then the coil does too. Give yourself a tick if you got that right. That's then going to induce a potential difference across the ends of the wire. Mark those 2 right, you get 1 mark for potential, 1 mark for difference. And that is the electrical signal that the microphone produces. So final mark for the word electrical. Again, add those up, give yourself a score out of 4. And as always, if you didn't get the right words in the right places, make sure you've corrected it, so you've now got the second part of our explanation of how the microphone works. What we've looked at there in detail is how a dynamic microphone works. But we also have another type of microphone called a carbon microphone. And the structure's slightly different here. So behind the diaphragm in a carbon microphone, what we have are these granules of carbon. Now what happens is, as the sound wave hits the diaphragm, then the resistance of the carbon is changed. What that means then is that a current passing through the carbon granules is going to change, because if we've changed the resistance of the carbon, we're going to change the current that passes through it. And that then means that we get that different electrical signal being produced, which is what we're going to get coming out of our speakers in time. Which leads us very nicely onto the second device we're looking at today, which is the loudspeaker. Now, loudspeakers are like motors at the end of the day. What we can actually do is you can make a dead simple one just using a paper cone, a piece of wire and a pair of magnets. And if you really want to do that, then Google instructions on how to do so. What we'll actually find then is that by connecting the ends of that wire to a changing potential difference of a suitable frequency, you're going to then hear a sound. So what we're doing here is producing a sound that's then going to be emitted as our sound waves. In terms of how the loudspeaker does this, then remember this is actually having a changing potential difference. So that changing potential difference will produce a changing current. We know this, it's the link we've had throughout many of these lessons. That changing current is going to then produce a force on the coil of wire, which we can see in the diagram on the right hand side of your screen there. Now, what we'll find is the reason we get that force on our coil of wire is because if you look surrounding it, we have a magnet. So it's within a magnetic field. And as we said back at the beginning of this topic, if we have a current carrying wire within a magnetic field, a force will be exerted on it. So that coil is then going to move as a result of this. Because that coil is then going to be behind our cone, as we can see there, and the diaphragm of our cone, then that's going to make it move in and out. And as the cone is moving in and out, it's going to obviously be compressing those regions of air particles to create those compressions and those rarefactions. So that means we're going to produce a pressure wave, our sound wave, and that is going to travel through the air. The way that we're going to have the difference in our sound is because the movement of that coil does depend on the size of the potential difference. So because we're getting that changing potential difference, we get the changing current. The movement of the coil is then changed because it's getting a different force exerted in the magnetic field, and so the cone is going to move to a different extent, creating different amounts of pressure within our sound wave. So make sure you've got those points written down. I'll just leave it up for another minute in case you've not got that. Last thing to do today then are the plenary questions. So 3 questions for you to have a go at in your books. I'll leave those up there for about 3 minutes today, but as always, if you think you need longer, then you can just hit pause and take as long as you need to do this. So this now marks the end of P4 for us. What I'm going to do is I'm going to set another assignment for you on Shobi. So I will send you all the instructions on how to access that via your school email addresses. I'm going to give you a week to get that handed in for me, so make sure you get that and finish it off, upload it as soon as you're done so I can then give you some feedback on it. But that's another unit now done. We're going to move on to P6 next, which is all about radioactivity and so on, because that one's actually a better one to do via home learning than the P5 topic, which I think is far better for us to do when we're in school together again. As always, you can find the answers to the plenary over on my website, scienceright.weebly.com. You'll also be able to find that under the Internet tab. Just select the week that we're in, and then you'll be able to find things like the lesson PowerPoints, the answers to the plenary, any additional work, and if there's any little experiments I thought you could do at home, then they're there too. So have a look and get using that.